Energy and Matter, Philosophical Reflections. Disclaimer. Before we move on with the rest of the chapter, I must emphasize that I am not a physicist, so words like quantum, quark, antimatter, gluon, space-time, black hole, or dark matter cause me discomfort. My knowledge of physics is about 25 years old, and it would be challenging to refresh it entirely. Therefore, I should clarify that my philosophical thoughts on energy, particles, and other theoretical and experimental physics might be questionable. However, let us engage in a philosophical discussion by questioning and contemplating. Since this is a philosophical discussion, one should approach it skeptically while being open to the concepts discussed in this chapter. It is basically a banter and blabber of a biologist's physics. One of the most well-known stories in physics is the tale of the apple, Newton, and gravity. While we do not know exactly what happened at that moment, according to Newton's account of the incident to Stukely, who relayed it, after dinner, the weather being warm, we went into the garden and drank tea under the shade of some apple trees. He told me he was just in the same situation as when formerly the notion of gravitation came into his mind. It was occasioned by the fall of an apple as he sat in a contemplative mood. Why should that apple always descend perpendicularly to the ground, thought he to himself. Whether or not the apple fell on Newton, we will retell the story with humor. In our retelling of the story, let us imagine an apple about to detach from a tree and fall on a blissfully snoring Newton. The apple drops from the branch, lands on Newton, bounces a little, and then falls to the ground. The apple becomes the hero of our version of the story because it performs the entire action and, importantly, awakens Newton. Newton wrote in one of his letters to Richard Bentley that gravity must be caused by an agent acting constantly according to certain laws. But whether this agent be material or immaterial, I have left to the consideration of my readers. So let us consider it further and discuss two important aspects regarding energy. From a philosophical perspective, two questions arise. Who owns the energy and who is affected by it? In this scenario, we see three instances of motion: the apple falling toward the earth, bouncing off Newton's head, and coming to rest on the ground. Who owns the energy responsible for these movements? The earth owns the energy that pulls the apple downward due to gravity. When the apple bounces off Newton's head, the energy ownership shifts. The apple, moving against gravity, possesses the bounce property, suggesting that the apple owns the energy for the bounce. However, Newton's head and apple contribute to the bounce, indicating shared responsibility. Energy is intimately linked with motion and change, moving or causing movement in the entities it interacts with. The more rapid the change, the more energetic the system. Energy is the agent of motion and transformation, perpetually driving the dynamics of the universe. I am not particularly fond of the phrase potential energy. The apple's energy is merely a result of its position, obstructed by the branch and influenced by Earth's gravity. It is Earth's property, its gravitational pull, that mobilizes the apple, not an intrinsic energy possessed by the apple itself. In the following section, we shall discuss a little deviation from traditional physics. The universe in its entirety is composed of four fundamental components that are intrinsically linked to the concept of existence: energy, matter, space, and time. For the purpose of our understanding, let us assume that energy and matter are interchangeable, space is infinite, and time serves as an account of changes that energy and matter undergo as they traverse space. Energy and matter, in this framework, can be seen as two extremes of a mass spectrum. Light representing the lowest possible mass and the most thermodynamically stable molecule symbolizing the highest. The vast majority of forms of energy and matter exist somewhere in between these extremes, implying that all entities have a matter component and an energy component. The fundamental components of the universe, energy and matter, are often discussed in terms of their distinct features and properties. While both are interrelated, they manifest in contrasting ways, with energy often symbolizing motion, repulsion, and transformation, and matter representing stability, attraction, and cohesion. One might envision energy as a voyager and matter as a settler. Energy is dynamic, forever in motion, while matter tends to remain stationary. Energy cannot remain in a fixed position unless contained by matter. Matter, by its very nature, acquires mass, which in turn generates gravity. This force of gravity attracts nearby objects, causing matter to expand and occupy more space. Energy, in contrast, is restless, always seeking movement and never content to remain in one place. This tendency to move is intrinsic to energy, even if not entirely understood. Matter, being static by nature, remains loyal to its designated space unless acted upon by energy. As depicted in the diagram, that is, the dual nature of existence is elegantly captured in the interplay between pure energy and pure matter. This philosophy rests on two opposing yet complementary principles that define the universe's dynamics. Pure energy is the epitome of motion and repulsion, traversing space in waves. It is characterized by high energy density and an inherent drive to expand and disperse. As energy transforms or interacts with constraints, it gradually transitions, adopting properties associated with mass and attraction. The declining energy density curve represents this change as it moves closer to the realm of matter. Conversely, pure matter represents stability, mass, and attraction, governed by gravity. Its intrinsic nature is to remain stationary, consolidating and binding through its gravitational pull. The curve of mass and attraction ascends as matter moves toward greater density and cohesion, contrasting the declining trajectory of energy. This concept reflects duality. Energy diminishes in motion and repulsion as it approaches matter, while mass and attraction rise symmetrically. Together, these two states define the universe's foundational duality. Energy creates motion while matter anchors existence in form and structure, embodying the cyclical unity of all phenomena. Most of the entities that we see in the universe have an energy component and a matter component, and because of these, they behave the way they do. The more energy content there is, the more motion and repulsion there is, and the more matter content there is, the more stability and gravity there are. Living organisms exist at an intermediate stability due to their high energy content. Unlike non-living entities, which are predominantly matter-based and inherently stable, living systems require a continuous influx of energy to sustain their complex biochemical processes. This high energy state makes them prone to degradation, as energy is constantly dissipated in maintaining order. Without continuous energy input and active maintenance, the structural and functional integrity of living systems deteriorates, leading to death. In contrast, matter-dominated entities with lower energy requirements persist longer in a stable state, emphasizing the fundamental link between energy content and transient biological existence. Energy, the embodiment of motion and repulsion. Energy is defined as the ability to move or the potential for motion. It is inherently dynamic, constantly in motion unless contained by matter. One of the purest forms of energy, light, epitomizes this behavior. Light energy is spatially unstable, always moving through space unless it encounters an obstruction. The motion of light, which travels at approximately 300,000 kilometers per sec, reflects its restless nature. It is driven by the inherent need to disperse, symbolizing repulsion. For instance, electromagnetic radiation propagates outward from its source, such as the waves of light emitted by a vibrating charged particle. This ability of energy to propagate across space without physical support underscores its role in the universe as a force of expansion and dynamic change. Regardless of form, the underlying theme of energy is its capacity to move, change, and affect other entities. This movement is crucial to processes like the transfer of energy, where energy flows between objects and drives interactions across space. Matter, the essence of stability and attraction. In contrast to energy, matter is defined by its stability and attraction. Matter is characterized by its mass, which is directly related to its gravitational pull on other masses. Matter's mass gives rise to gravity, which pulls other objects toward it. This fundamental property of matter ensures that it remains anchored in space unless acted upon by an external force, contrasting sharply with the ever-moving nature of energy. Matter exists in various states: solids, liquids, gases, and plasma, each with its own set of properties and behaviors. In solids, matter is tightly bound by strong intermolecular forces, giving it a fixed shape and volume. Liquids, while maintaining a constant volume, adopt the shape of their container. Gases, conversely, have neither a fixed shape nor volume and expand to fill the available space. Plasma, in stars and lightning, consists of highly energized ionized particles exhibiting high energy levels and dynamic interactions. Despite these variations, the unifying feature of matter is its ability to maintain stability and resist motion in space to varying degrees unless influenced by external energy forces. One key characteristic of matter is its tendency to attract other matter. This attraction is observed in gravitational interactions, where masses attract one another, such as in the revolution of planets around stars. In atomic and molecular scales, attractive forces, including nuclear forces and electrostatic interactions, bind particles together to form stable structures. The binding of protons and neutrons in atomic nuclei and the attraction of electrons to the nucleus in atoms exemplify matter's intrinsic tendency to maintain cohesion and resist dispersion. Matter's stability contrasts sharply with the energetic dynamism of energy. Matter, once formed, tends to remain static, resisting movement unless external energy is applied to overcome its inherent stability. This resistance to motion is fundamental to the concept of mass and inertia. Matter plays a role in maintaining the structure and stability of the universe, acting as the foundational element that provides coherence to physical systems. The interconversion of energy and matter. One of the most profound discoveries in modern physics is encapsulated in Einstein's famous equation, E equals c² squared, which reveals the interchangeable nature of energy and matter. This mass-energy equivalence suggests that, when sufficiently concentrated, energy can give rise to mass, and mass can be converted into energy under the right conditions. This realization has led to groundbreaking scientific advances, including nuclear reactions and particle accelerators.